Right. So we'll do the 2023 paper, data management. Right. Again, you have, I think, about 20 questions. And sorry, 25 questions. And you can see only one correct answer, only one correct answer. So make sure you read the paper. Sometimes only one correct answer, sometimes multiple answers are there. Okay. Right. So let's move on to the question number one. Which of the following statements are true regarding inheritance in the object model? So this is more related to object-oriented programming. Inheritance promotes the reuse of existing type definitions. Yes, because subclass inherits non-private attributes and behaviors. The supertype inherits all functions of the subtype. No, it is other way. Subtype inherits from supertype. Wrong. A type lattice means you get something like this, sort of a graph like a situation. Okay. So that is due to multiple inheritance. Single inheritance will create sort of hierarchical thing. Type lattice is due to multiple inheritance. A type lattice is created as a result of multiple inheritance. Yes. So the answer is 1 and 3 only. D. D. This answer is D. Second one. Imagine an online platform named Connect You, designed to create a dynamic community where a user can discover new connections and explore common hobbies. Okay. There is a need to manage huge amount of interconnected data. Okay. So these are important words within the network, allowing for efficient traversal of relationships and providing friend suggestions and targeted content recommendations, something like social media like Facebook. Which one of the following data store is more suitable to facilitate the above requirements? You can see huge amount of interconnected data. And you need to provide some suggestions and so on. That means it's sort of a network-like situation. You need to identify the interrelatedness. Okay. Key value, white column, graph, relational, document. So interconnections are best mapped using the graph database because you can see the associations, right? Aggregations and so on. So I'll go for B. Right? I'll go for B. Third one. Which of the following statements are true regarding data-centric XML documents? Data-centric. Okay. XML, remember XML can be structured. Sorry, mostly XML is used for semi-structured or unstructured. Data-centric means more better structure is there. Other one is what? Document-centric. Document-centric means less structured. It's more unstructured. Okay. But some sort of a structure is there. So data-centric means it will be better structure. There are no structured data elements in the document. No. Data-centric means structure is there. These documents generally contain long-running text. No, long-running text is document-centric. That is how you subdivide, right? Data-centric, document-centric. These documents usually have predefined schema that defines the tag names. Yes, data-centric means you have predefined schema, right? Okay. So if there's no predefined schema, it is more document-centric, right? So I'll go for 3. I'll go for C. Yes, it is C. Fourth one. Consider the SQL statement given below that creates student table, right? Student ID is primary key. Which of the following insert statement doesn't result in any constraint violation? So you must pay attention to the constraints. Primary key is student ID, it can't be duplicated. First name not null, last name not null, date of birth null allowed, but date, gender 1 character, and it must be either capital M or capital F. NIC must be unique. You can't duplicate it. Right. So which ones are the not null fields? Only optional field is date of birth gender, NIC. Those are optional. First three fields are must. Student ID, first name, last name, must. But date of birth, gender, and NIC optional. Okay. But there are some constraints for those. Insert into student ID, first name, last name, date of birth, gender. So here you try to insert null value to first name, but first name is not null column. So therefore, this will give you error. Right. Second one, you are not adding null, but here you can see gender. You try to enter X. So gender only capital M and capital F is allowed. So therefore, it also violate this check constraint. Student ID, first name, last name, date of birth, gender, NIC, 5 Eve Williams, 1985-45, female, F is allowed, and this is the NIC number. It can take up to 12 characters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks okay so far. D, first name, last name, date of birth, gender, NIC, values 6 Sam Roberts, first name, last name, date of birth looks valid. M is valid. Gender is capital M, and NIC is also looks valid. So it looks okay, right? But only one answer is correct. So therefore, let's keep it open. Next one, student ID, first name, last name, date of birth, gender, NIC, right? So that also looks okay, right? But only one, which of the following does not result in any constraint violation. So that means out of these three, two of those are still should be having issues. I can't see it right now. Let's again see. Student ID, first name, last name, date of birth, gender, NIC. 5 Eve Williams is the date of birth. Female. So it looks okay, right? Can you see any issue? Because only one must be valid. Insert into student ID, first name, last name, date of birth, gender. Anyone can see issue? Because only one must be correct. Who seeks student ID, first name, last name, date of birth, gender, NIC. Still, I can't see issue. I don't know. I'm blind to that error. Is it a spelling mistake? Student ID, first name, last name, date of birth, gender, NIC. No, right, correct. Because this part is the same in all. Student ID, first name, last name, date of birth, gender, NIC, right? Student ID, first name, last name, date of birth, gender, NIC. So that part is the same. Only the second part is different. Okay. This is 23561. Eve Sam John Williams Roberts Doy 1985 for 25 1998. This is not valid date, right? 1313. So you can't have 1313, right? Because 13 is not a valid month. So therefore, we'll take this out. Okay. I think that kind of small mistakes are there. Right? Anything you can find? In C, there is 13 characters for NIC. 13 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. right? So that is the issue. So therefore, this is also wrong. So you can see the examiner is doing very small issues, giving small issues, right? So 13 characters are not allowed because only 12. So then definitely answer must be E because this looks okay, right? Right. So then the answer must be E. Okay. Yes, answer is C. Okay. Right. So that is a tricky one. Actually, not very tricky one, but sometimes it's not very obvious thing. Right. Fifth one. Which one of the following concepts involves using different database technologies to handle different data storage requirements within an application? So if you use different database technologies within same application, that means you are using bit of relational database, and also for some data you connect to the NoSQL database. So we call that polyglot persistence. That is directly from your note. Okay, polyglot persistence. So that is mentioned directly in your note as well. I'll go for A. 6. Consider the computer system which contains 1,000 blocks of unordered file records, unordered, right? No order. How many blocks need to be accessed when the search criteria is satisfied by multiple records? Anyway, multiple records are also there. So therefore, when you find it, you can't stop it. Okay. So you need to keep finding. And also unordered. So that means you can't do even linear search. Right? Of course, you can only do is linear search. But again, you can't stop at middle. You need to keep searching until the last block. Okay. That means number of blocks access is number of blocks itself. Okay. Right. So 1,000 blocks are there. So therefore, you need to search each and every 1,000 blocks. Okay. Each and every 1,000 blocks. It's not average. It's us in general because multiple possible means you can't stop at the middle also. Okay. Therefore, I'll go for B. 6, I'll go for B. Yes. 7. Which isolation level ensures that transaction avoids lost update and dirty read? So that is something you need to remember and answer these kind of questions. We did these things in transaction handling. So if it is lost updates and dirty reads are not allowed, but phantom reads are allowed. Right? Phantom reads are allowed. So remember the best is serializable. Best you can reach is serializable. Right? So this is not serializable because phantom reads are allowed. So therefore, the next best is okay, repeatable reads. Repeatable reads. So 7 must be A. 8. Consider the relation employee given below. Right? Employee given below. The primary key is underlined. So this is the primary key. Which one of the following index structure is most suitable to efficiently retrieve the details of employees based on their whether married or not and gender? Okay, so remember married or not is sort of a flag. Married, not married. Yes, no. Gender is also sort of a flag, right? Male, female. So for when you have only few options, right? Few options, what kind of index we can use? So definitely not B plus trees. Because B plus trees is when you have low values and you are doing range queries and so on. Okay. Hash, no, you don't need to go for hashing because hashing is when you have big range mapped to a small range, but this is definitely a very small range, just two values. Function based index, when you need to do some calculation, like you want to convert to uppercase, right? Maybe some other calculation. So here you don't see any calculation, right? So when we have just one or two values and out of those we need to get one, remember bitmap. Remember the bitmap, right? We can say one or zero. So gender is either one or zero, right? This one also either one or zero. So therefore we can save this bitmap as our index file. Now, if you are looking for married people, so then you know which records you want to see. You want to see males, so you can just go through the bitmap index file. Right? D. 9. Which of the following statements these are true regarding span and unspanned files? Right. So span means your record can go into two blocks. Part is in one block, other part is in the other block. So what we discuss is our calculations all unspanned because just when you consider the block size and record size, usually one record share in two blocks is usually not required. But of course, if your record is very large, yes, it might be worth. And the other thing is for simplicity of calculation, we always use unspanned. Okay, right. Which of the following statement is are true regarding spanned and unspanned file organization? Each record will be stored only one block in a span file organization. Span means it can go into others. Okay, can go into that means one record can be in multiple blocks. Okay. So therefore, this is wrong. Span means one record can go into multiple blocks, but it says only one block. Span file organization will be used wherever, whenever the record length is larger than the block size. Of course, if the record length is larger than the block size, we have no other option but going for the span because there's no other option, right? We can't increase the block size. So yes, so they are the only possibility span. That means huge records. Unspanned file organization optimize the utilization of unused space. No, because unspanned means you can't break it into two blocks. So if your block size is, if the remaining space is say 1 MB, and if your record size is 3 MB, now you can't put it there in unspanned. So that means you are a bit of wasting bit of thing just to make it simple. So therefore, it's not better you optimize utilization. Actually, we compromise the utilization for simplicity. Okay. And also, unspanned means you keep it in the same thing, but it says portion of the record in one block and other part is in the other block. So that is also wrong. So therefore, we'll say only two. We'll go for B. 10. Cap theorem. Remember, we did discuss the cap theorem in the afternoon session also. Transaction handling in NoSQL databases. So there are three factors. We can only achieve maximum of two factors, not all three. That is what cap theorem. That means we need to compromise one. The cap theorem is the fundamental concept in distributed databases and explain the trade-offs among the key properties, consistency, atomicity, and partition tolerance. Atomicity is not related to that, right? So atomicity is not related to a cap theorem. Okay. So therefore, we will not take that. Partition tolerance ensures that every request received by a non-failing node in the system must result in a response. So partition tolerance means when there's a communication breakage between some nodes, still it should work. Maybe there's an issue here, but still system must somehow working. Okay. Maybe some nodes are still serving. Every request received by non-failing nodes in the system must result in a response. Is it consistency? Sorry, is it what is mean by that? I'm not very sure about that. Okay, let's see the third one. According to the theorem, a distributed system can prioritize at most 2 out of the 3 properties. Yes, we can only prioritize 2 out of 3. Right? 2 out of 3. So this is no. Let's read the. Let's go through the note because I'm not very sure about this partition tolerance. Partition tolerance. So it should be at the very last. It should be transaction handling, right? Yes, it should be in transaction handling, not distributed databases. Let me open the note. Somewhere at the bottom. Right, cap theorem. Consistency, availability, partition tolerance. Okay. It is possible to enforce only two. Okay. Right. Consistency, availability, partition tolerance. This is the one I am not very sure about right now. The system continues to operate despite communication breakages that separate the cluster into multiple partitions which are unable to communicate with each other. That means there's a communication breaking. Still, system continue to operate. Right. So I'm not very sure how it is done. But even though there are communication breakages, maybe there's a communication breakage between these two, it says still the system must work. So that means there should be at least multiple communication lines. Like maybe this is not there, maybe this can, there's an alternative communication through this one. Maybe this one is communicated with this one and this one is communicating with this one. I hope that something like that. Okay. Uh, right. So now let's read the answer. Partition tolerance. Ensure that every request received by a non-failing node is, I think non-failing node stuff is for availability. Right. So that must be availability. Request received by non-failing nodes in the system must result in response. So that is availability. So that is not the partition tolerance. Okay. So therefore, we'll say this is wrong because this explanation is not for partition tolerance, but for the availability. So therefore, we'll go for 3. See 3. Okay. Right. So let's double check the answer. I'm not very sure. Maybe yes. Because this is, yeah. Anyway, third one is definitely correct. Okay, we'll check the answer. 10. Yes, C. Okay, C. 11. Which of the following statements is are true regarding the distributed databases? It involves collection of independent databases on non-network computers. Independent databases, non-network computers. So that is wrong, right? So the distributed databases means it is the same database, right? They are communicating and collaborating, not independent, and also in network environment, not non-network environment. So I say no. It consists of single central database. If it is a single central database, that is not distributed. Data items are generally stored closer to the location where they are most required. Yes, so that is one of the objective for performance and availability. Let the databases stay closer to the users. Right? Distribution increases the complexity. Yes, of data synchronization. Yes, because your data is in different places. That is one of the disadvantage. I'll go for 3 and 4. D. D. Consider the schema given below related to employee table. Primary key is underline and foreign key is italics. Which of the following SQL statement add constraint where the employee age should be greater than 18 and less than 65? Okay. Greater than 18, less than 65. Greater than, right? Not greater than or equal to. So therefore, definitely A is wrong. Right? So from that, we can straight away get rid of some answers. 8, this is less than or equal. This is also greater than, less than, equal mark is there. Now we have 2 answers. Create both the assertions. In both the assertions, not constraints. not check constraints. Create assertion age constraint, check. So, so what is mean by assertion? Usually we go for assertions when your constraint is complicated one, involving multiple tables and so on, right? Okay, let me double check that because I'm a little bit out of touch about the assertions. Let me open the note. Indexes and constraints. What is assertion? Not indexing and tuning, right? Yes, it should be, right? Let's read the UCSC note. Assertions. It's mentioned about assertions. Why? Which note is mentioning about that? I think assertions you had in semester 2 database, right? Not semester 3. This not this, but this assertions. I think there was somewhere database constraints and triggers. That is the one we need to look at. Constraints and triggers. Okay, so that is one we are supposed to look at. So see where the assertions are there. Yes, assertions. Constraints in databases as assertions. An assertion is a condition that allows entering valid values to the tables. It get enforced on any number of other tables, right? So you can see assertions can be applied to multiple tables. Usually the normal check constraints are related to one table. So if you have broader general validations, you need to go for assertions, right? Or any number of other rows in same table. Remember that usually constraints are for one record, but this is for any number of records rows as well. Assertions differ from check constraints since assertions are defined on schema level. Check constraints related to one single row only, right? Correct, right? And hence are defined on a column or a table level. Enforcing assertions are complex in nature, therefore most of the DBMSs do not support it. Okay. So anyway, for this one, you don't need assertion. Actually, the check constraint should work, but they have used assertion. Okay. So create assertion name, check, and your condition. Okay. Like this kind of complex things, assertions are used. Okay. And now let's look at the question. Right. So now we know that it should be assertion anyway. So the question is, Which one of the following SQL statement adds constraint where the employee age should be greater than 18 and less than 65? Okay. Check not exist. Not exist. Select from employee E dot age is less than 18 or age is greater than 65. That means you need to find if there are any records with age less than 18 or greater than 65. So you need to check whether not exists. But what we need to see is we need to check whether exists, right? If exists only, is it assertion? Yeah, is it exist or not exist? You, not exist means valid. Okay. Should we write valid case or invalid case? I think we need to now in constraints we write the valid case, right? We write the valid case. Uh, Other than that, it's whether exist or not exist, right? Check exist. If exists, it should fail, right? Yeah. So therefore, I'll go for D. I'll go for D. Okay. Right. What is the answer given? 12. Answer given is E. How come C? Because it says less than or but it's there it says not exist, right? So there it's check not exist. Now only I found that it is not exist. Okay. So then what is wrong with the other one? Create assertion age constraint check not exist. Select all from employee where age is less than or equal to 18 or age is greater than or equal to 65. I think that is correct, right? Not exist because it says not exist. But then what is wrong with this one? When they say not exist less than 18, that is wrong because 18, because then 18 is included, right? Greater than 18 should be greater than 18. So this does not check whether equal 18 because it says not exist. So they check for the not exist condition. So therefore, when you check for the not exist condition, 18 must be included because 18 is wrong. So that is why C is not correct. Okay. Then why D is not correct? So out of C and E, yes, E should be correct. C is not correct because it's you are looking for the not exist. Then what's wrong with D? Check exist. Okay. But when you do check, you need to look for the wrong condition, right? So this is you are looking for the correct condition. So constraint must be check for the no, right? So the check say male or female. Yeah, we check for the correct condition, right? But this is not the correct condition. This is the wrong condition. Less than 18 is the wrong condition. If it exists less than 18, it's a wrong condition. So we are checking for the correct condition. So this is the correct condition. Yes, E is the answer. Right? So remember, check constraint must check for the correct condition. This is the wrong condition. Less than 18 or greater than 65. So therefore, correct condition is properly checked uh, here because your age must be greater than 18 and less than 65. Okay. So the answer is C. Anyway, it's a very tricky way the examiner has written the constraint. Actually, you don't need an assertion for this. We could have easily write check constraint, but I think check constraints you can't write this kind of a thing. But we can just check. You can use four conditions. Okay, I think this should have been easily done using normal check constraint without assertion. But anyway, if you go for assertion, E is the correct one. Right. So it's a little bit complicated question because it's use assertions. Okay. So usually assertions are very rarely used. Like 13. Which of the following statement these are true regarding consistency in NoSQL? Right. Logical consistency, session consistency, eventual consistency. So eventual consistency means initially there can be inconsistencies, but after some time it must be consistent. That is the normal approach in NoSQL, because NoSQL data is semi-structured and blah 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 and high workload and so on. Session consistency means for the given session, user session, it must be consistent because it is your changes. Your changes must be visible to you. If, maybe not for others, but for you, it must be consistent. Eventually, others will also see. So logical consistency, that one I'm not very sure. Okay, let's read the one by one. Logical consistency always ensure that the same data item has the same value when read from different replicas. I'm not very sure about that. Session consistency in SQL databases ensure that within a session, client will observe its own update. Yes, right? Eventual consistency is preferred though immediate consistency in NoSQL databases. Yes, because immediate consistency will add additional complexity. So they are, because of the highest workload and so on, this is not very practical, immediate consistency. But immediate consistency is expected in relational databases. So therefore, I'll go for 2, 3. And there's nothing called all are correct. So therefore, I'm not very sure about the first one. Still, because all are correct is not there, I will go for D. Let's first check the answer. 13, is it D? Yes. Now let's double check what is logical consistency, because I honestly I can't remember logical consistency. So this should be in distributed databases. Okay. Right. Ensure that different data items make sense together. Ensure that different data items make sense together. Replication consists ensure that same data item has the same value when read from different replicas. Session contains within the user session there is a read where there is read your write consistency. It means once you have made an update, you are guaranteed to continue seeing that update. That means at least you should see the your update. Replica means when you read the same data from multiple nodes, you should get the same value. Okay. So same data item has the same value when read from different replicas. Logical consistency ensure that different data items make sense together. So that means if there's a transaction, if you add something, say money transfer, the two balance must be consistent. Okay, but logical consistency usually you achieve after some times, not immediately, because okay, uh, right. So anyhow, answer is correct because all answers were not there. I just picked D. 14. Consider a data file containing 40,000 records stored on a disk with block size 2048. So we did this kind of calculations, right? Block size is 2048. 40,000 records. The file the file record have a fixed size of 80 bytes. One record is 80 bytes. 80 bytes. And are unspanned. So that means only one block, one record goes to one block. What is the number of blocks required? It's a typical question, right? First, find the block factor, number of records per block. That is 2048 divided by 80. I hope this is divisible by 8. Say 8 to 16. Then 44, 5, 40, 48, 6. Yes. So block factor is 25.6. But you can't keep zero point 0.6. So therefore you need to, you can keep only 25. Remember, you need to floor it. So the block factor is 25 records per block. Now you can calculate how many blocks required. Number of blocks required is, altogether we have 40,000 records. One block you can keep only 25. So number of block is this. Okay. And this must be seeding, because number of block is 10.5 means 11 blocks. Right. Let's divide by 5. 5, 8, 0, 0, 0. 1, 6, 0, 0. 1,600 blocks. You don't need to seed it. Exactly 1,600 blocks. 14, I'll go for C. Yes. Right. So now you must be very comfortable with this kind of calculations. Okay. 15. Which of the following statements are true regarding hashing techniques? Remember, hashing techniques are used to map bigger range to a smaller range. Hashing techniques are not good for range queries, but individual queries like someone's email address, not for salaries and something like that. Okay. Hash functions is applied to records hash field. Yes, records hash field, and returns the address of the disk block where the record is stored. Correct, right? So hash function will give you the block. I'll say yes. Collisions occur when the hash field value of a record that is being inserted hash to an address that already holds another record. Yes. So if two values result in the same hash value, it's a collision. Of course, collisions cannot be fully prevented. Right? Collisions are part and parcel of that. But we try to minimize the collision by finding good hash algorithms, which evenly distribute your values. But this is correct, right? This is what is called known as collision. The collision problem will never occur. No, right? Collision is always possible. We try to minimize. In external hashing, since many records can be hashed to the same bucket without generating issues. But yes, this will reduce the collision because we have buckets of these. Okay, but it will not eliminate. Right? I don't think that it will eliminate. Let's read the note again, whether it's mentioned. So this should be related to indexing and tuning. So let's see whether they have mentioned about buckets. Yes. It's related to external hashing. The target address space is built up of buckets, each of which stores many records to match the properties of the disk storage. A bucket is continuous group of disk blocks or single disk block. That means we basically make it bigger. Rather than allocating an absolute block address to the bucket, the hashing function translates a key to a relative bucket number. The bucket number is converted into matching this block address via a table in the file header. Okay. Since many records will fit into a bucket, can hash to the same bucket without generating issues. The collision problem is less severe. You can see collision problem is less severe. It doesn't eliminate. It can reduce the collision. Okay. It can reduce the collision. So therefore, so the bucket is not going to eliminate duplication or collisions, but reduce the collision. right? Reduce the collision. So therefore, never occur is not a good answer. Okay, never occur. So therefore, I'll go for 1 and 2. D. Yes, answer is D. Okay. 16. Consider the following SQL statement used to create the purchase table. The purchase table has references to two other relations, customer and book. Right? So that means two foreign keys are there. Yes, one for customer, one for books. Okay. Which one of the following statement is true regarding referential constraints? So for customer, on delete restrict, on update cascade. For book table, on update cascade, again on update cascade, but on delete set null. Right? So on update is the same cascade. That means when you change the primary key here, all the foreign key values must be changed. Say my say custom ID is changed here. Usually primary key values are not allowed to change, but anyway, let's allow say 5 to 10. So then all the foreign key values are also changed from 5 to 10. That is means update cascade. Delete restrict means, right? So when there is a purchase, you can't delete the customer. Restrict means that you can't delete the customer. First, you need to delete all the purchase and then come back and delete the customer. Set null means, say, when you delete a particular customer, if there are purchases for that customer, all these purchase records, customer ID set to null. Set to null. Okay. Sorry, not to purchase. The set null is for book. If there are books, we set that customer ID to purchase ID to purchase number to null. Okay. Right. So A. Updating customer ID in purchase table. Will update the customer ID in the corresponding record in customer table. Update in purchase table. This is not updating purchase table, right? Updating in customer table. So referential integrity is written here. But for example, say employee and department, that is the one we are very familiar, right? So the foreign keys are in not department table. Foreign key is in the employee table. Right? So then when a particular department ID is updated, here the foreign key values are updated. So therefore update happens here. When there it happens, here also it happens. So that is the idea. Okay. But here it says in the purchase table when it is updated. But no, this is when customer table it is updated, purchase table it will also updated. So that is how the referential integrity works. Okay. So therefore A is wrong, right? A is wrong. Deleting the customer ID in the customer table will restrict if there is a corresponding record in the purchase table. Right. So now it's going to delete in the other table. Right. Customer table. Yes, delete restrict, right? So when you delete a customer in the customer table, it is restricted as long as we have purchasers for that customer. So remember that is how the referential integrity works. If when you do that stuff in that table, it will be restricted or cascade or whatever. It is not when you change purchase table record, right? When you delete or update the other table records. So that is correct. So if you try to delete a customer, if there is a customer, same customer ID is referred in my purchase table, it is not allowed. It is not allowed. So, okay, so therefore that looks okay. Updating customer ID in customer table. Right. Customer ID in customer table, yes. Will set the customer ID to null. But here you don't see anything like set null for this customer table foreign key. So therefore that is wrong. So that set null is for the book table. Deleting a book in the book table. Right. So remember, delete set null. Deleting a book in the book table will restrict. No, not restrict, set null. Updating of the ISBN in the book table. But there's no ISBN is there. Foreign key is ISBN. Okay. So when you update, it must be cascade. Will set ISBN to default. No, not set default. It is cascade. When you change there, he also change. So we'll go for B then, right? B. Yes. 17. Consider the following database schema about three relations: user, post, and like, related to social media platform. Primary keys are underlined, foreign keys are italics. Okay. Which one of the following SQL statements create trigger to update the like counts attribute of the post relation after new like is added to the like relation? So it must be after insertion. So therefore, before insert statements are wrong. I will get rid of that. B is wrong because it's a before insert. It says after. All the others are after inserts. Okay. Update the like counts attribute of the post relation. So the trigger will change the other table. Okay. Post relation is updated after new like is added to the like relation. Okay. Right. So let's read it again. Create trigger update like trigger, that is any name. Any name. After insert on like. Yes, after insert on like table. For each row, that is how you write triggers. Begin and end is there. Update post, set like count equal current like count plus 1, where post ID equal new post ID. Yes, you need to refer to it as new post ID. Okay, so let's read the other one also. Anyway, B is wrong. Create trigger update like triggers after insert on post. That is pretty much the same as previous. For each row begin, end, update post, set like count equal like count plus 1, where post ID equal, is it the same thing? Create trigger update likes trigger after insert on post. Right, after insert on post. So likes are added to the post or like. This is the post. Post has the like count, but likes are added to the like table, right? So therefore, this trigger must be triggered when like is added to the like table. So then the update is done to the post table because it has a like count, but you must write the trigger to the like table. So this is on like, but this is on post. So therefore, this will not work. And these two again like, this is post. So therefore, this will not work post also. Now we need to find between A and D. Okay. So the first part is the same. Create trigger, update likes trigger after insert on like. For each row, begin update like. Set like counts equal like counts. So there's no like count in like table, right? So the like table, you don't have the like count. Like count is in the post table. So therefore, this update statement is wrong. Right? So this update statement is wrong because you are supposed to update the like table, not the post table, because there's no uh, attribute called like count in post table. So therefore this, sorry, there's no like count in uh, post table. Sorry, like table. So like count is in the post table, right? So therefore, there's no such field in like table. So therefore, you can't update like that. But there's a uh, like count in post table. Okay, you can see in the post table you have the like count, but in like table there's nothing called like count. So therefore, we need to settle for A, right? Which question is that? 17. Yes, A. Okay, answer is A. Okay, so let's continue. Right. So now we move on to the question number 18. So 18 and 19 is based on this description. Consider the following scenario to answer question 18 and 19. The student file has 50,000 student records stored on a disk with block size B 8,192 bytes. So let's draw this question. What is the number of blocks access required to perform a binary search in the data file without using any index structure? Without using any index structure. Right. Student file has 50,000 student records. I'm looking for some space. Okay, maybe we can copy paste this. Okay, let's copy paste this. Okay. So this space is not enough. Right. So let's draw it. Student file has 50,000 records. Altogether 50,000 records. Stored in a disk with block 8,192 blocks. Say one block is 8,192 bytes. File records are fixed size and are unspanned. Fixed size unspanned. Each record is 200 byte long. So one record is 200 byte. It's a typical question, okay? Student records are ordered on the key field student ID. Suppose a single level primary index is there, is created on the key field student ID. That means you have primary index, which has a student ID and again, the block size is the same, 8,192. So there's a primary index also. Okay. Each index entry is 80 byte long. So each index entry is 80 byte long. This is 200 byte. Okay. Right. So, but the first question, you don't need to refer to this because it says without using any index structure. Okay. But this is sorted, physically sorted by student ID. Okay, student ID. So therefore, you can do a binary search without index entry. So therefore, the log2 number of blocks, because you can take the first block, second block, not the first block, second block, you can go to the middle, it's middle, okay, because you are doing the binary search. Okay, so what is the number of blocks required? So first calculate the block factor. I'm calculating it not for the index file, this one. This is for the data file. Block factor is number of blocks in one, sorry, number of records in one block. That is 8,192 divided by 200 byte. 200 byte. So that is divided by 200, 4096. That is 40.96. Right? 40.96 records per block means you need to floor it. You can have only 40 records. 40 records in one block. But we have 50,000 records. 50,000 records. So therefore, number of blocks for the data file equal 50,000 divided by 40, because one block can have only 40. 0, 0, 2, 25, 0, 0. That is 12, 1250. 1,250 blocks. So number of blocks required for the data file is 1,250. It is sorted on student ID. Is it student ID? Yeah, student ID. So therefore, you can do binary search block by block, middle block, its middle block, and so on. So therefore, the number of blocks required for the worst case also log 2,250. Right. I'll go for E. Right. 18, I'll go for E. Let me double check the answer. Yes, C. Any questions about that? Is it clear? Because we did that to last week, right? Right, 19. 19 question. What is the number of block access required to perform binary search on index file? Only for index file, okay, not the additional access. So remember, when it comes to primary index, because this is already sorted, you need one record per block. That is the first record of each block. Okay. So therefore, number of blocks required is 1,250. So that means you need 1,250 entries. 1,250 entries. Okay. And each entry is 80 byte. So therefore, block factor for the index file is number of records per block, 8,192 divided by 80 byte. I will use the calculator, but you can't use calculators unless they allow. I think this, of course, this is not to preserve time. 8,192 divided by 80. 102.4. 102.4 means you need to floor it. Okay, I lost my pen. Okay, let me close and come back. Oh, no, now I can write. Right. 102.4. That means 102 records only, because you need to floor it. So block factor is 102 records. So then how many blocks are required? Number of blocks. In one block, you can have 102, but there are 1,250 records. 1,250 divided by one block, you can have 102. This time you need to ceiling. 1,250 divided by 102. 12.25 means you need 13 blocks. 13 blocks. Now you can do the binary search here. Just 13 blocks are there, sorted. So therefore log 213. Because the question is how many block access required to perform binary search on index file. Of course, if you are accessing the record, you need one more access because the block pointer then go there. But it says only for binary search on index file. So therefore, I will not add one anyway. The plus one is not in the answers. 19, I will go for B. B. Yes, B. Okay, so it's a typical primary key index question. Right, 20th question. Which one of the following statement falls regarding replication in NoSQL databases? Remember, in NoSQL databases, we can do replication for better performance, better availability. Okay. First one. All the replicas have equal weight and are responsible for processing updates in peer-to-peer replication. All replicas have equal weight. Peer-to-peer means they are the same. Remember, master slave means you do the update to the master, right? So then the slaves, master will push it into the slaves. So slaves are used only for read. Right? But in peer-to-peer, every node has same status. Same status. And any node can be updated. And also from any node you can read. So therefore this is correct, right? So I don't know whether equal weight is the correct, right? Maybe you can use relative importance, but in general, yes. Peer means same. It's a correct one, but we are looking for the false. If the master fails, okay, this is if it is master slave, slave can be appointed as a new master. Yes. So if a master fails, it is directly mentioned in your note. There's automatically you can configure that one of the slave is automatically upgraded to master, or manually you can assign one of the slave as the master. This is directly mentioned in your note. If the master fails, the slave can be appointed as a new master manually or automatically in the master slave replication. This statement is straight, right, as it is mentioned in your note. Master slave replication is suitable for read intensive systems. Correct, right? Because in master slave, all the slaves are used for read. All the slaves are used for reads. Okay. So then slave nodes, they don't need to worry about updates because updates are pushed to the slaves by the master. So master slave is better when read intensive. But when you have sort of a both read and write sort of a same sort of importance, go for peer-to-peer because then any node can be updated. Here you need to update the master. So therefore, it's good when you have more reads. The master is responsible for handling read queries, while the slaves are designed to handle write queries. It's other way. Master is responsible for write. Of course, master can be write and read. Slaves can be only read. So therefore, this is other way. Read-write inconsistencies can occur in peer-to-peer replication due to slow synchronization of data. Okay, so that can happen in both. Okay, because when it is unlike the master slave. In master slave, all the slaves are connected to master because master is supposed to push it. But in peer-to-peer, there can be because this peer, when there's update on this peer need to push it into other peers. Right? It is little bit more work than master push it because master has a dedicated role, but now it can be a little bit more complicated. So therefore, it's yes, there can be read-write inconsistencies in peer-to-peer application due to slow synchronization of data. Okay. So in general, that is the case. Because anything can be updated. But anyway, in master slave also, there that possibility is there, but less. Here, the possibility is a little bit more severe. But if you need a lot of updates, the best approach is also peer-to-peer. Okay. Right. So therefore, the obviously wrong answer should be D, right? 20, I'll go for D. D. 21. Consider the patient schema given below. Note that primary key is underlined, patient ID. Patient relation is horizontally fragmented in way that patients with age values less than 30 are separated from patients with age values greater than or equal to 30. It's a horizontal partition. Some records are in maybe one side, other records are in the other side. It's horizontal. You can see horizontal, not vertical. Vertical means some fields are in one side, other fields are in other side. Which one of the following fragmentation condition is suitable to reconstruct the original relation? That means you need to union age greater than or equal to 30 and age less than 30. Less than 30, other one greater than or equal to 30. Ultimately, all the records must be there. Okay. Less than 30, greater than or equal to 30. So this is less than 30, but this is 5. This is a join. So it can't be join. It can't be a join. It must be a union. This is again 5. It must be sigma. Okay. So then sigma less than 30 union greater than or equal to 30. Correct, right? This looks correct. What about this? This is less than 30, greater than 30. Then the equal is missing. Right? Equal is missing. So then obviously answer must be C. C. Yes, answer is C. Okay. Right. That is not difficult. We see 22. Okay, it's a big description. Vertical fragmentation. Consider the product table given below related to an electronic shop. Note that the primary key is underlined. Right? Product ID is a primary key. The database administrator wanted the product table to be fragmented based on the following rule. Fragmented product relation into two sub-relations so that supply information will be stored in supply info table and product details in product info. Okay, so that means definitely vertical fragmentation. Some columns in one table, other columns in the other fragment. But there should be a common field, which is primary key. Otherwise, you can't reconstruct. Fragment the product relation into two sub-relations. So this supplier table. Okay, so but okay, supplier info and product info, correct. Then fragment the product relation into two sub-relations, product mobile and product laptop. That means both horizontal and vertical, right? Because first we subdivided into supply and product. Then product is subdivided into product mobile and product laptop based on the distinct categories of the mobile phone and laptop responsibility. So that is based on category. So it's a hybrid approach. Which of the following relational algebraic expressions is used to represent vertical fragment of the above scenario? I think it is only interested in vertical. So it must be using phi, not sigma. Okay, not sigma. So therefore, I will get rid of these sigma ones. Okay. Because you need to break it into supply info and product info. Of course, then you need to do horizontal one, but the question is about vertical fragmentation. So therefore, I will not consider these sigma ones, rather 5. Right. So original table is product table. Right. Original table is product in both product mobile, product laptop, provide supply info, product info. So we are interested in vertical. Right. It must be supply info, product info. Right. So the product table here, you need product ID. Now remember this, you need the primary key in both. In both, you need product ID. Then supplier name, supplier address, that is supplier details. Product name, category and price, that is product details. I will go for B. Okay. Because this is something else. Yes, 5 is correct. But when you do 5, there's nothing called category equal this. That is for sigma. So therefore, A is definitely wrong. So answer must be B. 22, I'll go for B. Yes. Yes, the subject is difficult, but if you have properly studied, you can get A plus. Only thing is you need to understand the subject. You must have spent some quality time understanding, not memorizing like parrot. Right, 23. Consider the following 5 schedules based on 3 transactions, T1, T2, T3. Using read and write operations on data item X and Y. Note that each RI, WI, CI, and AI denotes read, write, commit, and abort operations belonging to transactions TI respectively. What is the non-recoverable schedule? Right. So remember we discussed about schedule, whether it's serializable schedule, then whether it's recoverable or not. Right. Non-recoverable. Non-recoverable means one particular transaction has already committed. Now, when the other one failed, now you can't recover because other one is already committed. Dirty reads. Dirty reads values are transaction is already committed. Okay. Right. So again, if you have forgotten these, just go through the video, right? Recordings, okay? Because I'm not going to do the revision again because you have the recordings. Right. This one is non-recoverability. Shall we copy this because I need a little bit more space for this again? Right. Read to X, read to, write to, commit to, read one, write one, commit one. So let's say this is transaction 1, this is transaction 2. Read to X, read to Y, write to X, so write to Y, write to X, commit to, it's like a serial transaction, okay? Read one X, write one Y, sorry, X, commit one. So this is a serial transaction. Serial transactions are always recoverable because after finishing this only you are doing the other one. So therefore this shouldn't have any issue because it's serial. Serial transactions are always safe. Right. So therefore this is not going to give me an issue. Second one, read one, write one, read one, read to, write one. This one has some swapping in mixing. Right. Read one next, transaction 1, write one next, read one Y, read 2x, second transaction read x, write 2x, write 1y. Then you commit this, right? And then you commit second one. Right, now let's see whether we have that kind of issues. So this is write value, which you read and write again. So this is dirty value, you read that dirty value. Right? But remember, though you read that dirty value and you write it, you are doing the commit after this commit. So therefore, if this is rollback, that is the idea. If this rather than commit, if there's a rollback here, that means your read value is wrong because this write value you read, but this one has been rolled back. But now, after this commit, you are doing this commit. So therefore, if this roll back, this can also be rolled back. So therefore, this is not having any non-recoverable schedule. This is recoverable because when this is rolled back, this is also can be rolled back. That is called cascade rollback. So cascade rollback is okay. But if you had done this commit before this, so it's other way, like this, then it is non-recoverable. So that is this commit is done first, then we commit this. Then after committing this, that commit is based on this dirty read. But now this is rollback. Now what to do? Because this one is already committed. But this is not issue. This is not issue because its commit sequence is correct. Commit sequence is correct. Okay. C. Read 1x. Write 1x. Read 2x. Read 1y. Write 1y. Write 2x. Abort 1, abort 2. Okay. Remember, AI denotes abort. Rather than rollback, they use the abort because R is used for read. Okay. So now, first one is aborted. Second one is also aborted. So here you can see again there's a dirty read here. This dirty value is read here. Okay. And that value is again you have use and write also. Now this has aborted. That means this one has been rolled back. But no issue. When this is rolled back or aborted, you can roll back this because this is done afterwards. So therefore, this is okay. Because though we have a dirty read, the way we do the commit sequence, of course, it's either commit to abort. When this is aborted or rollback, we can roll back because this should be rolled back because this right value is then wrong because this is all undone. So therefore, this is not an issue. Right. So far, so good, right? Right. Read D, read 1x, write 1x, read 1y, sorry, read 1y, still in the first transaction. Right. Read 1y, read 2x, write 2x, write x, write 1y, commit 2, and then abort 1. Now again you can see there's a dirty read. This written value, dirty value is read here. But now you can see clearly this dirty value is read and written. Now you have already committed. Second one is already committed. After second one is committed, now only the first one is aborted. So aborted means this right value is undone. But that dirty value is already used and written. So that means this right value is wrong. because this guy has aborted for rollback. But already you have read it and you have committed your transaction. So this is now not recoverable because by the time this is aborted, this is already committed. So this sequence is wrong. It should have been first you commit to abort the transaction one, then do the transaction two. But you have completely messed it. So therefore, D is having issue. Irrecoverable schedule. Okay. So D should be the answer. But anyway, let's check the E. Read text, write text, already committed. That one is interesting. Right. Read one next, write one next, then commit that. Then read 2x, write 2x, read 2y, write 2y. So anyway, it's a serial schedule. Serial schedules are always safe. So no issue with that. No issue with that. Because serial schedules are okay. Because after this commit or abort only you start the next one. So therefore, definitely the answer must be D. 23, I'll go for D. Yes, D. Okay. Right. So we have two more questions. Right. It's a precedence graph. So you must not have cycles. Remember, we did these kind of questions. I think maybe we have done this question also already. Consider the following schedule S1, which consists of three transactions T1, T2, T3, and the data items X, Y, Z. Note that each Ri of Wi denotes read and write operations. Belong to transaction Ti. Which one of the following proceedings graph correctly represent the schedule S1? Right. So let's draw the schedule precedence graph. So I will arrange this like T1, T2, T3. Okay, because that is easier for me. T1, T2, T3. This is read 1x, read 2x, second one also read x, write 2x, read 3z, read 3y, read 2y, read 2z. I'm running out of space. Okay, I'm running out of space. Let's do it more compact manner. Right. So read 1x, read 2x, write 2x, read 3z, read 3y, read 2y, read 2z, write 3z, read 1y, write 1y, write y. Right. So what is the precedence graph? Say T1, T1, T2, T3. Okay, let's draw like that. T1, T2, T3. Remember, the dependencies are between different transactions only. For the same transaction, it's not a dependency. Read is not a dependency. That means at least one operation must be a write. And of course, the same data must be there. X and Y, there's no dependency. X and X, there's a dependency. Even kids can understand this, okay? Very simple thing. Right, so let's do this. Read text, read text. It's both read, no dependency. Read text, write Y. Two different transactions, same data. And one operation is, at least one operation is write. So now we have dependency. That is T1 to T2. So Z is a new data. This is Y. Y is a new data. First, right? So this is the first time Y is used. This is also read by, but it is read read. Read read is not an issue. At least one operation must be right. And this is again read DZ, read DZ. Though two different transactions, both are read, no issue. Right. So then we have read Y. Write text is there, read Y is there. You can see write read. Write read. Sorry, it must be same data. X and Y has no issue. This is Y. So here read Y is there, but read read is not issue. Here also read Y is there, read read is not issue. So therefore no issue. Okay, no issue. And what about this write is it? Before that, actually, I should have look at this write is it. Definitely there's a dependence. Read is it, then write is it. Okay, that is T2 to T3. T2 to T3. Same data, one operation is right. At least one is right. But this ZY has no issue. Sorry, read Y has no issue. Read Y has no issue because this is also read. Write Y is not written yet. Then you have the write Y. Now, write Y and read Y has a possible conflict. And also here also read Y and write Y. So that means 2 to 1, 3 to 1. 2 to 1, 3 to 1. So that is my precedence graph. Do we have something like that? Is it C? T1 to T2, T2 to T1? Yes. I'll go for C. I'll go for C. 24, I'll go for C. 24, it's A. Why is that? T1, T2, T3, T1 to T2, T1 to T2, T2 to T1, correct. T1 to, sorry, the answer is not C, answer is D, because here we can see T2 to T1, T2 to T1. But what I get is T1 to T2, T2 to T1. Actually, the answer is not this one, because here T2 to T1, T2 to T1. Actually, I did not pay attention to that. So therefore, answer must be D. Here you can see T1 to T2, T2 to T1. No, not D also. Not D. A. Because D also correct wrong because both are T1 to T3, T2 to T3. But what we have is T2 to T3, T3 to T1. A is the answer. Right? A is the answer. T1 to T2, T2 to T1, T2 to T3, T3 to T1. Yes, answer is A. Right? Answer is A. So 24 answer is A. Okay. It is my mistake. I draw the correct precedence graph, but when I look at the answers, I was careless. Okay. Right. Final question. Consider the schedule provided below, which involves two transactions T1 and T2. The initial value of A and B are 1000 and 2000 respectively. The initial values of A and B are 1000 and 2000. A is 1000, B is 2000. What are the potential values of the values variable sum after execution of write sum? Right, that is write sum. Here also there's a write sum. Okay, there's no write sum in the other transaction. Write sum after execution each write sum operation in T2. That means you need two answers. Yes. Taking into account that transaction T2 is executed under two isolation level, read uncommitted and serializable respectively. First one is read uncommitted, a serializable read. So serializable means no issue at all. All the issues are tackled. This is a difficult question actually. Okay. So let's say if it is under serializable, because I can't remember what is read uncommitted is. Okay. Therefore, let's see serializable. So read A, read B. A is A into 2, write A. Read A, read B. So there's a read here, write here that write is now read. Write to read. So there's a dependency write to read, okay? Then read B. Anyway, that is fine because no write. Then write some. That is fine. A to T1 to T2 dependency is there. Then here we have read B. Right? There's a read B here and there's a write B here. So that means T1 to T2 is there, T2 to T1 is there. So there's a cycle. T1 to T2, T2 to T1. So therefore, this can't be done. Okay, this cannot be done because then it is not serializable, but it says serializable. So then what should happen is this must be delayed. This must be delayed. Okay, until this is done. Okay, until this is done. Because otherwise cycles are there. Then of course you have the read A, read B, blah blah blah. Right. So let's assume that this is delayed. Anyway, this is a difficult question. We delay this up to so that we do it after this. Of course, it is not we do, it is what the database system do. Because otherwise it's cyclic. Okay. I'm not very sure whether my answer is going to be correct. I'm just going through my intuition. Okay, this is a difficult question anyway. So let's assume we delay. That is what my logical thinking says. Okay. And see what is the result is there. Okay. So let's see we delay this until this is done. Okay. This is done. So that means both should be the same because we need to delay this. When we delay this, both times you should get the same results, right? Because this is you write it, you read, then you do the sum, A plus B. But anyway, it should be the same thing. Okay, so what is the initial value of A? 1000. Initial value of B, now 1000 has become 2000. Right, now A is 2000 after this line. Then you have written it. Now that value you have read it. So therefore A plus B must be now 2000 plus 2000, 4000. Now you write the sum, 4000. And now again you read A and B. I feel like this must be delayed, otherwise they are cycle. Okay, so then again the same values are there, 2000, 2000, and the sum is still 4000. I'll go for 4000, 4000, but there's no answer for 4000, 4000. Right? 4000, 4000 answer is not there. So that means my thinking is not correct. I thought the same value will be there because this is done afterwards. Okay. How to do that? Anyway, this is the last question. They have given somewhat tricky question. Okay. So that means you should know internally what happens, not just the normal way. Okay. It's basically you need to go through the locking mechanism to understand this. Okay, we'll keep this question open. Maybe I will have a look at it again because this is the first time I'm looking at this question. Okay. I never got a chance to go through this paper because this is a 2023 paper. So I will again have a look at it, have a look at of this, and maybe we can, if I get a, but I feel like this very tough question anyway. Anyway, if I get a mechanism or some sort of a clarification, I will let you know in the next class. Okay. Right. So we'll stop at this point. So next week again, I will try my best to add another extra class. Okay, another extra class. If you, but no holidays. If there are holidays, I can even add a morning session. But if I am running out of options, I will even add a weekday morning session, right? Weekday morning session also. So those who can attend, you can attend because we need to finish it. But anyway, they have not called for the exam yet. That is strange because the deadline is also already elapsed. Right? Deadline is already elapsed. I don't know whether they are going to delay the exam, but very rarely they have done that. Almost never. When they publish the exam schedules, most of the time exams are on schedule. Okay. But I don't know why they have not called for the. But what you can do is don't think that there's a delay. But because that is normally there are no delays. So still they have enough time. Maybe they can call for the exams Monday and they can give 1 or 2 weeks. Right. So that might happen possibly. Because if there's a delay, they should have published it. Okay, so therefore just do your studies normally. So therefore I will add more extra classes also to do more and more past papers. Okay. Uh, and we will target in 2 weeks, 3 weeks time finish most of the past papers. Okay. Because now because last week I had to add more extra classes to semester one students. Now semester one, most of the past papers are done for them. Therefore I can borrow some sessions from semester one. Okay. And actually, this one is also I borrowed from another class because you guys are a little bit behind. Okay. Right. So we stop at this point.